Welcome back to Dr. Fogg's TV.
Good day everyone, I remain your humble Dr. Fox. So today we are going to physics, that is resistivity and conductivity. Resistivity and conductivity. Now, when we talk about resistivity, we say that resistivity is defined as a resistance per unit length per degree positional area. That is resistivity. This is it. This was resistance per unit length per unit cross-sectional area of the material concerned, which means that resistivity is Ra over L. So I'll call this equation 1. That is resistivity. Ra over L. So from there, I will say area, we call that area is pi d square over 4. Now, there are some questions whereby you be given diameter. So when you are given diameter, the formula for area becomes pi d square divided by 4, which means that my resistivity is R multiplied by pi d square over 4 divided by L. So resistivity is R pi d square over 4 times 1 over L. Resistivity becomes R pi d square over 4L. So I'll call this equation 2. Now, I can also say that we call that area is pi r squared. Recall that area is what? Pi r squared. So whenever you are given radius, the formula for area becomes pi r squared. So I will say that my resistivity is r pi r squared divided by what? L. So resistivity is r pi r squared over L. I'll call this equation 3. Now, for us to get the units of resistivity, to get the unit, so resistivity is Ra over L. So to get the unit, R is resistance, and resistance is measured in ohms. A is area, and area is measured in meter square. That is meter times meter. And L is length measured in meter. So from here, I will say meter cancel meter, and resistivity the meaning becomes what? Ohms meter. Now, for conductivity is the reciprocal of resistivity, which means that conductivity is K because to 1 divided by what? Resistivity. That is what? Conductivity. So to get the unit of conductivity, then this is 1 divided by 1 ohms meter. So if I bring ohms meter up, it becomes what? Per ohm meter. So that is the unit of what? Conductivity. So having explained the concept behind resistivity and conductivity, then we go further to solve our question. Question 1. It says, what is the resistivity of a cylindrical material wire whose length is 1.0 meter? So my length is 1.0 meter, has a resistance of 2.0 ohms. Resistance is 2.0 ohms. The diameter of the wire, diameter is 0.5 millimeter. Now, and I am looking for the word resistivity. I know that resistivity is Ra divided by L. Resistivity is Ra over L. Now, since I'm giving diameter, my area becomes pi d squared divided by 4. But there's a problem, and the problem is that the diameter is in millimeter. So I have to convert from millimeter to meter. So I will say diameter is 0.5 millimeter to meter diameter becomes 0.5 divided by 1000. So from millimeter to meter is divided by 1000. So here becomes 5 times 10 raised to power minus 4 meter. So my area pi is 3.142 times 5 times 10 raised to power minus 4 all squared divided by 1000. So the area is 3.142 times 5 squared is 25, then times 10 raised to power minus 8 divided by 1000. According to indices, is divided by 4 by g squared over 4. Sorry about that. Now, according to indices, the power inside multiply the power outside. So my area becomes now 3.142 multiplied by 25. That will be 78.55 times 10 raised to power minus 8 divided by 4. So the area is 78.55 divided by 4. That is 19.664 times 10 raised to power minus 8 meter squared. So my resistivity is 2 times area, which is 19.64 times 10 raised to power minus 8 divided by the length, which is 1. So resistivity here becomes 19.64 multiplied by 2. That is 39.28 times 10 raised to power minus 8. Now carry this number in standard form. And the rule of standard form says that my point must stay between the first and second number. So I move the point here. That is 1. Resistivity becomes 3.93. I've approximated times 10 raised to power minus 8 ohms meter. So that is question 1. So very quickly we move to question 2. Question 2. It says calculate resistivity and conductivity. So I'm looking for resistivity. I'm also looking for conductivity of length 2 meter. Length is 2 meter and cross-sectional area is 0.004 centimeter square. If its resistance is 3.0 ohms. Now resistivity is RA over L. Now my area is a centimeter square. So I will convert from centimeter square to meter square. So which means that my area is 0.004 centimeter square to meter square. So it becomes what? 0.004 divided by 100 times 100. Now if you are converting from centimeter to meter, is divided by 100. Now for square units, the 100 appears twice. So from centimeter square to meter square is divided by 100 times 100. Therefore cubic units, the 100 appears 3 times, which means from what centimeter cube to meter cube is divided by 100 times 100 times what 100. So which means that area here, let's use standard form. Here is 4 times 10 raised to power minus 3 divided by 1 times 10 raised to power 4. So the area becomes 4 times 10 raised to power minus 3. This is 4. When it comes up, it becomes what? Minus 4. So the area is 4 times 10 raised to power minus 7 meter squared. So I will come here and say resistivity is RA over L. That is 3 multiplied by the area, which is 4 times 10 raised to power minus 7 divided by the length, which is 2. So I will say 2 here 1, 2 here 2. So resistivity is 3 times 2, that is 6 times 10 raised to power minus 7 ohms meter. Now, conductivity is the reciprocal of what? Resistivity, or the inverse of resistivity. So conductivity here becomes 1 divided by 6 times 10 raised to the power minus 7. Here becomes 1 divided by 6, that is 0.167 times 10. This minus 7, when it comes up becomes what? 7. A negative part coming up becomes what? Positive. And a positive part coming up becomes what? Negative. So my conductivity here is 1.67 times 10 raised to the power minus 1 plus 7. Conductivity becomes 1.67 times 10 raised to the power 6, then per ohms meter. So that is question 2. We move to question 3. A wire of length 100 centimeter. So the length is 100 centimeter and cross-sectional area of 2.0 times 10 raised to the minus 3 centimeter square. So the area is 2.0 times 10 raised to the minus 3 centimeter square. Has a resistance of 0.10 ohms. Then calculate its electrical conductivity. Now, before you get the conductivity, you also need to calculate what? Resistivity first. And we know that resistivity is Ra over L. That is our formula for what? Resistivity. Now, my area is 2.0 times 10 raised to the power minus 3 centimeter square. So to convert from centimeter square to meter square, the area becomes 2.0 times 10 raised to the power minus 3 divided by 100 times 100. So the area is 2.0 times 10 raised to the power minus 3 divided by 1 times 10 raised to the power 4. So the area becomes 2.0 times 10 raised to the power minus 3 minus 4. So the area becomes 2 times 10 raised to the power minus 7 meter square. So resistivity is Ra over L, 0.10. Oh, that is my area is 2 times 10 raised to the power minus 7 divided by the length. The length is also in centimeter. So to convert centimeter to meter divided by what? 100. So if I divide this by 100, I have 1 meter. So which means that resistivity is 0.10 multiplied by 2. That is 0.2 times 10 raised to the power minus 7. Here, standard form, that is 2 times 10 raised to the power minus 1 minus 7. Resistivity is 2 times 10 raised to the power minus 8 ohms meter. Now, conductivity is the inverse or reciprocal of resistivity, which means that my conductivity is 1 divided by 2 times 10 raised to the power 8. So my conductivity becomes 1 divided by 2, that is 0.5, that is 0.5 times 10 raised to the power minus 8. This is a positive power coming up because of negative. So here becomes 5 times 10 raised to the power minus 1 minus 8. So here becomes 5 times 10 raised to the power minus 9 per ohms meter. So we move to number 4. A 2 meter wire, length is 2 meter. Of resistivity is 5.5 times 10 raised to the power minus 7 ohms meter. Has a cross-sectional area is 0.50 millimeter square. Calculate its resistance. So this is what I have. Calculate its what? Resistance. Now, resistivity is Ra over L. That means resistance becomes resistivity L divided by what? Area. Now, but my area is in millimeter square. I want to convert to what? Meter square. So the area is 0.50 millimeter square to meter square. The area becomes 0.50 divided by 1000 times 1000. Now, from millimeter to meter, you divide by 1000. But from millimeter square to meter square, because of the square unit, 1000 appears what? Twice. So my area here becomes 5 times 10 raised to power minus 1 divided by 1 times 10 raised to power 6. So the area becomes 5 times 10 raised to power minus 1 minus 6. This plus, breaking it up becomes negative. So the area becomes 5 times 10 raised to power minus 7 meter square. So my resistance becomes 5.5 times 10 raised to power minus 7 times 5 times 10 raised to power minus 7 divided by the area, okay, times length. Sorry. So times length, my length is 2 divided by the area, 5 times 10 raised to power minus 7. So my R becomes 5.5 times 2. That is 11 times 10 raised to power minus 7 divided by 5 times 10 raised to power minus 7. So resistance becomes 11 divided by 5. That is 2.2 times 10 raised to power minus 7 plus 7. This is negative. Bringing it up becomes what? Positive. So my resistance becomes 2.2 times 10 raised to power 0. Here becomes 2.2 ohms. Because anything raised to power 0 is 1. So we move to number 5, which is the last question. A wire of 5 ohm resistance, that means R is 5 ohm, is drawn out so that its new length is 2 times its original length. Now, before there was a new length, it means that there was an old length, but the old length was not given. They said so that its new length will be 2 times what? Original length. The original length is now the was old length. So I'll call the original length L1 to be L and L2 to be 2L, new length. So new length is 2 times original length, which means that the original length has a value. That was why it was what? Doubled when it was new length. If resistivity of the wire remains the same, that means they have the same resistivity, and the cross-sectional area is half. Now, before you have the area, there was an initial area. I will now call the initial area A1 to be what? A. Then A2 is A1 over 2, which is A over 2. Then calculate is what? The new resistance. That is R2. And I will call this one R1. So I'm looking for the new resistance. Now, I know that resistivity is RA over N. Now, then here becomes RA over N equals to RA over L. Now, don't forget that it was resistivity is what? Is constant. So I'll call this one 1, 1, 1. I'll call this one 2, 2, 2. So you are equating. Now, R of R1 is 5. Area A1 is A. Divided by length L1 is N. Equals to R2. Okay, the R2 is unknown. Now, the A2 is A divided by 2. Then divided by what? The L2 is 2L. Now, in this case now, my A cancel the A. L cancel the what? N. If you have the same thing at left hand side and right hand side, you can cancel out. So in this case, I have 5 equals to, here becomes what? R2 divided by 2, then divided by 2. So 5 becomes R2 over 2 times 1 over 2. So 5 equals to R2 over 4. So my R2 becomes 5 times 4, and the R2 becomes 20 ohms. So this is everything on resistivity and conductivity. So make sure you view, like and subscribe to the YouTube channel. Watch out for the next class.